obviously take a minute and make sure that you've read through the question carefully. A couple things that I want you to take note of. First of all, let's also look at the fact that this is the graph of the derivative. That's important. Next thing is it's telling you that we are satisfying f of negative 2 equals 7. Okay. Now, so let's talk about that for a little bit. We kind of touched on it, but not really. So I'm going to start with part A, and we want to know what is f of negative 6 and also f of 5. So let's do negative 6 first. So what we're always going to do is we're always going to start with that condition that they gave us, which was f of negative 2 is equal to 7. So what you're going to do is you're going to write down f of negative 2. I'll explain it in a minute. Plus the integral from, all right, now here we go. We're starting with f of negative 2 because that's the value, the x value that they gave us. So then what you do is whatever x value they give you, so in this case it's negative 2, in another case it might be a different number, we always make that the lower bound, okay? All right, so I'm going to put a negative 2 here, and then our upper bound is always going to be what value we're looking for. So in this case, we're looking for f of negative 6. So negative 6 is going to go up here. Okay? All right, so I'm going to go like that. All right, well, I know what f of negative 2 is. They gave it to me. I know that that's 7 plus. Okay, now the next thing that you need to notice is that this is a problem, right? Because negative 2 is actually larger than negative 6. So remember, we need to flip these bounds and we need to negate this integral. So I have a plus here and I have a plus here. What I'm actually going to do is I am going to go backwards and I am going to get rid of that plus. And I'm going to turn it into minus. Okay, because I'm going to flip again. Just remember, I'm going to take these bounds right here and I'm going to flip them. All right, so now remember what this means. This is just the area under the curve from negative 2 to negative 6. So essentially, it's looking for the area of that triangle right there. Okay. All right, well, we know the area of a triangle is 1/2 the base, and the base of that triangle is 4, and the height of that triangle is 2. So we just work that out. And that's going to be 7 minus, what is that, 8, half of that is 4. So that's 3. So then I know that f of negative 6 is 3. All right, now the next one that they ask us to find is f of 5. Now this is going to follow the same pattern. So again, they gave us a value, which in this case was f of negative 2. Plus, we always integrate, and I'm going to repeat myself again. Whatever number they give you here will be your... Okay, sorry about that phone call, but I forgot where we kind of left off. So I'll recap. This is the value that they gave us initially. So remember, whatever x value this is your lower bound. And then my upper bound here will be 5. So I'm going to put negative 2 here to 5 there, and then we're going to work this out. Well, I know again f of negative 2 is 7 plus, okay, now here I'm integrating from negative 2 all the way up to 5. So that means that I will be finding the area under the curve from negative 2, let's say, to positive 2. And then from positive 2 to 5. And the reason why I'm splitting that up hopefully is obvious to you, that I'm going to take the area of this half circle and this area of the triangle, and I'm going to add them up. Now please remember though, that look at where this half circle is. That should tell you something about its area, right? All right, so what does that tell you? That tells you that you are going to actually have a negative area, right? Where the area will be negative because the area is under the curve, under the x-axis. Whew. Okay, So it's a half of a circle, and remember pi r squared, so the radius is 2, which makes that 4 pi, but that's for a full circle. We have a half circle, so that's going to be 2 pi. Okay, plus 1/2 the base of the triangle from 2 to 5, right? And if we count, that's 1, 2, 3. Oops, 3 times the height of that triangle, which is 2. Okay, so this right here then would be 3, right? Okay, so then we have 7 minus 2 pi plus 3, which is going to give me 10 minus 2 pi. Part B is asking on what intervals is f increasing. Remember what the word increasing means? That would be where the derivative is positive. Well, lucky for us, we have a derivative picture. So I am going to do a derivative sign chart. And remember, if you have a derivative picture and you want a derivative sign chart, what do you look for? You look for above and below. So I am above till I get to -2. I am below until I get to +2, and then I am above after that. Okay, now let's see. So it says on what intervals is f increasing? Well, increasing will be where the derivative is positive. So we do have -6 as one of my endpoints, and the other one is 5, right? So I would say -6 to -2, or from 2 to 5, because f prime is positive during these intervals. All right, so part C wants us to find the absolute minimum value. Well, remember again, if I see the word increasing, decreasing, maximum, or minimum, you should be thinking derivative, so f prime. Now, we want the absolute minimum, so we do have to look at the minimum that is the lowest. And remember, though, we also have this word value. Do you remember what that means? That word value means we want the y value as our answer. Okay, and we are going on a closed interval from -6 to 5. All right, well, we could take our answer from, or some of our work, I should say, from part B, and let's look at the sign chart that we had. So we had -2 to 2, we were positive, negative, positive, we had endpoints at 5 and -6. Okay, so a minimum, remember, if we have a minimum in a function, the derivative changes from negative to positive. So we would be looking for a minimum here at x equals 2. X equals -2 is actually a maximum, so that won't be an answer for us. But that means then that x equals -6 is a minimum, right? And that would make x equals 5 a maximum. Okay, so I currently then am looking at two values, -6 and +2, and I want to see which one is more min than the other. Okay, go back to your part A answer. Don't we already know what f of -6 is? Okay, so our f of -6 ended up being 3. So really all I have to do now is find f of 2 and see if it's lower than 3 or higher than 3. And then I have my absolute minimum value. So let's do f of 2 the way that we would have done it if it was in part A. So remember, we started out with f of -2, which we know is 7. And then we are going to add the integral -2 up to +2. Okay? All right, so f of -2 is 7. Now, if we look at the area under the curve from -2 to +2, we do see that that is a negative, so I'm going to change that plus sign to a minus sign. And we found this in part B, and we knew that it was 2 pi. So let's compare this answer here with this answer here, and let's see which one is lower, because we're looking for the absolute minimum value. Well, we know pi is 3.14. Now remember, this is non-calculator. So we know that this is 6 point something or other, and 7 minus 6 point something or other is definitely going to be less than 3. Okay? So then our absolute minimum value would be absolute minimum value would be 7 minus 2 pi. And then your explanation would be what I have right here, because the derivative changes from positive to negative about x equals 2. And you do have to state that f of 2 will be less than f of negative 6. Okay, so for part D, they're asking for f double prime of negative 5 and f double prime of 3. So I see that I have, again, graph of the derivative, and they're talking about f prime. So in relationship to f prime, f double prime is the derivative, right? Or the slope. So really what they're asking you to find is what is the slope of f prime at negative 5. So negative 1, 2, 3, 4, 5. So they basically want what is the slope of this line, because that would represent f double prime of negative 5. Okay, so I see that I'm going to just make my life easy here. I go down 2, and then I go over 1, 2, 3, 4. So that slope at negative 5 is negative 1/2, right? Okay, so let's write that down. So f double prime of negative 5. Now you could write it went down 2, then over 4, and you can leave it like that, or you can make that negative 1/2. That's totally up to you. Okay, now let's look at f double prime of positive 3. So that's the slope, right, at positive 3. The slope of f prime at positive 3. Well, let's find 3. 1, 2, 3. Ooh. So this is the graph of the derivative. What would the second derivative be at that point? This is the first derivative. What's the second derivative? Okay, so I'm hoping that you're all saying D-N-E, Miss Carter, because f prime of 3 has a peak or a cusp, which means the second derivative does not exist at that point. And there it is typed up for you, just so you can read that through.